Okay guys, here's a little project for you. If you don't like to spend $1,000 or more on an electric drive for your kayak, I have to give credit to the Bigsby Jet guys who turned me on to this particular kind of rudder that they use and adapt for their $500 nicely engineered jet drive, which is it really looks good. But for those of us who don't have $1,000 or more, this is what you can do. This is the same kind of rudder that they use. It is called a navigation rudder system. You can get these things from Top Kayaker, and it's made by Kayak Sport. They're about $100. Now, if you can also buy these from Bigsby Jet, but what they do is they cut off the end right here and attach their adapter for their motor. Now, what I'm going to do is use this because, as I'll show you in a minute, why the action of this is far superior to the normal rudders that flip up 180 degrees. The problem that creates for us is that you've got this heavy motor on the end of it, so trying to flip that up while you're seated in the front of it and have it flip up 180 degrees just doesn't work too good. So what I got here is an older model Minn Kota trolling motor that I've had for about 30 years. And what I did was I took off the pipe that screws into the motor. It's about a 17-pound thrust, and took out the switch, trying to remember where all of the wires are so that you can hook it up later. Take off the top, which is just a big funky container which held the switch and the control knob, which we don't really need with this. We also need to, which I've already done, that there's plenty of better solderers than me, that you need to add a little extra wire. I'm adding about 5 feet to it so that I'll have an 8-foot wire, which perfectly matches the 8 feet of shrink wrap tubing that I'm going to buy. It's going to be 3/8 inch tubing. So the reason we're doing this is, like I said, this is an example of one of those 180 degree things, rudders. You see? So right down here, if I were to attach that motor and trying to pull it up and make it go all the way up and around, it's going to be too heavy and probably break this or break this, which is not their own very good. So instead, we've got this navigation rudder system, which works like this. You pull it up, you cut it off here. We're going to attach that motor with some metal brackets that are going to be bent around and bolted into the rudder. I'm also going to have some old inner tube that will be in here. Around the motor to prevent a little bit of abrasion there. So that's what it looks like at the beginning. I'm going to start cutting through it. I'm not going to bore you with all the sawing and the cutting and the cussing and the fitting. Just show you what it looks like as I go and as I get through. One of the features of this rudder here also is that it has an anti-backup, so that when that motor is on here, if you want to reverse, that it has a lock right here. When you pull it to open it, it releases it and then pulls up. Pretty cool. Okay, here we go. What we're going to do is try to get a perpendicular cut fairly low on this rudder. So I'm going to use a little square. Take that. Get it perpendicular so the motor is gives you a perpendicular drive. Use that little box cutter there and scored it, and I will cut it at this point. Okay, I'm now committed to the project. I've just cut into a $100 Kayak rudder. Remove that piece. And right down here is where the old trolling motor is going to be fit. I'm going to go back to the original plan of using this metal strip with the holes in it. I used this many years ago to attach the seats to my boat, to my aluminum boat, which is my workbench right now. Anyway, these are a lot easier to deal with. You can use these to easily mold around there and then attach it with holes drilled into the rudder. When I get done, I'll show you what it looks like. So here's the finished product. It was much easier than bending those metal fence braces. They fit around like that. I use some tin snips to cut it. A little pair of pliers here to make the bends as I needed them. And so I'm going to drill the holes in the rudder at this point and make the attachment. Put the inner tubes donated by a neighbor on the inside of it. Be back shortly. Also, one thing prior to attaching those braces, you need to find the middle point of this motor by weight. You can attach a string right about here, or use your hand. Just kind of figure out whatever works for you so that it doesn't lean this way on the rudder. You want it to sit exactly parallel to the rudder. Okay, now that you've got the center point of the motor marked, I use a little colored string there. You see that it's centered fairly well. Now you're going to put those metal straps equal distance on either side of them, of that string, and attach to the rudder, not too close to the edges, so it doesn't wear through after you've had it there for a while. Alright, here's something I noticed that you're going to have to deal with if you're going to make this gadget. Is right in there, there's some gaps that you have to fill in. Now what I used was some polyplastic that I melted in there. You could probably use epoxy or even just some wood shims. But if you don't do that, what's going to happen is when this motor torques or gets some kind of pressure, that rudder is going to spin out and get caught at an angle up underneath the metal brace. So you're going to have to pack that with some kind of a shim. Take your pick. Also, you can see here I've got it all fitted with the brace bands. Not the brace bands, but the metal, and a couple of double nuts on there. That's not very aerodynamic, but then again, you're spending $100 and something rather than $1,000, so you could rig up whatever you want to cover those up if you want. I'm going to cut these two tops of the bands, paint it, and then put the shrink tubing on the wire, and show you what I've done when that gets done. Okay, here's a process in order to get the plastic backing the right size. So because of the thinness of the Kayak, I cut out a template like that. Now that's going to go on the inside. It's going to be a real chore to get it through that little deck plate all the way back to here, but we'll figure that out later. And then from that, I cut out this little piece of plastic, which is having to be bent using a heat gun in the shape that will fit on the back of that curved Kayak. So it's just about set now, and we'll move on to the next step. So here's the interesting part of this whole process. I've drilled holes in the back of the Kayak that will allow the bracket, or the gudgeon as they call it, to fit on the back of the boat. This piece, which I've custom curved so that it will fit on the inside of the Kayak as backing for the gudgeon to sit on the outside. Now the process that's tricky here, or interesting, is going to be putting these bolts through that backing, and we're going to tie a string onto, actually we're going to fish a string through these holes, a string for each hole that's going to be pushed back up to that deck plate, because I don't want to cut a hole in the Kayak and then patch it up. So then I'm going to tie those strings onto the end of these, pull them up through here, and then these bolts will be pulled through and will look like this, to which this will be attached and bolted to. So that's a good theory, and we'll see how it works. So now that I've made my clothes hanger a little bit longer, I've been able to fish this string all the way through and tie it onto the end of that bolt. I'm going to do that for the other 4 bolts, and this is going to slide in there along the bottom of this and be pulled up behind the back, the transom of the boat. Those bolts are going to pull through the hole, and then I'm going to attach the gudgeon to it with bolts. So I got one done. So here's this contraption getting ready to go in. I've got some silicone goop around there. I've got a couple of strings tied on to these 2 bolts. They should be pulled through these 2 bolts, through these, and soon to be installed. So here's the attached gudgeon and plastic piece that I explained about why it's there, to keep these from flexing as much. One of the other things that I had to do on here, once I pulled these bolts through that string, there's no way to get inside to hold that bolt to be able to attach these screws. So what I had to do was tighten these bolts up until I could get to a point to get a wrench attached here, and then tightened this way, and got a good attachment point that way. It's a little tricky, but it works. You got some lock nuts there that'll keep that from sliding out. Okay, after a lot of searching and experimentation, I figured out a way to get this switch into a housing. There's no plastic boxes available on the market that I could find that fit. It's about a 2.5 inch diameter on there with electrical connections on the side. So what I figured out, I've got some caps for 3-inch PVC. That's the same size as a PVC. I got a connector here. It fits down in there. Got it on both sides. And then this will go inside and sealed up. So, show you the finished product shortly. Getting close to the end on the controls. Neighbor made a decal. I attached the power cable attachment. There's a wire that goes to the battery box. These are 2 attachments that go to the motor. I tried to find a cup holder that had some Scotty mount on it, and apparently I measured wrong, so that doesn't fit in it. So I had to take off the little ridge attachment, drill a couple of holes in it, and fortunately there's an arch to this that's going to fit right there with a couple of screws which will be able to easily attach and detach. So we get that all put together, and so the gives the ability to take the entire unit off of the Kayak if you need to, so nothing's going to be permanently attached. Well, here's a semi-completed attachment put on with some small brass screws. So the way this works is like I described. It slides in like that and locks somewhat, and then that sits on any Scotty mount. Since one of the videos got corrupted during the editing, copying and pasting page, I wanted to show some details of the attachment of the rudder control to the rudder, along with the wiring. This wiring that went down into the top of the trolling motor has got some silicone down in there with the shrink wrap on that on all the wires, and then some cable covers which I didn't connect with clamps or tie wraps, just so that I could have a little flexibility and take them off if I need to. Comes out to that 8-foot distance with the female connectors that attach to the control head there. Anyway, close-up that I want to show you at this point is the attachments on the rudder control. There's a couple of clevis pins, one for the rudder control and one for the centering gadget that I made, so that the rudder would snap back to the center in case you had a rudder control problem. So there's little split rings that are there with a spring attached to some paracord, which is attached to a clip. Some people may recognize that as one of the parts that you use when you're making those paracord bracelets and watch bands and things. That's all that is. This is just a rubber hose that fits perfectly over that spring to keep that from rubbing onto the kayak. Anyway, the split ring is on the back side of this, so that the connector from the direction control clip on the back and have enough play on it, about 4 inches, to make it be able to move and give you a good turning radius. Hope that explains a little bit more of the details that went into the control on this, in case it wasn't clear in the first part of it. Here's a part of the rudder control steering system that I've set up. A couple of quick buckle releases here, with a rubber hose over a spring. This is to keep the rudder to swing back into a neutral position and make the steering a little easier. I'll probably switch this over to a bungee rather than these springs. They're probably going to wear out. But for now, this was the idea that I had. It seems to work so far. So here's the most difficult design feature of the whole project here. This is a hand steering control that I guess you could buy the Bixby control and not have to go through all what I went through. But this is a piece of HDPE, the high density polyethylene, about 1/2 inch, some scraps I had. We cut out a hole that will fit that bolt, which has a pulley wheel inside of there. That is a garage door cable pulley. There, I routed out a circle so that would fit in there on that 1/2 inch poly. A scrap piece of metal that uses a handle tightened up with bolts and washers that fits right in there. These holes are drilled to put in the rudder control sleeves. They'll fit right in there when I get it. I drilled a holes there that will go back to just in front of the rudder, and we'll connect onto here with a little swivel so that I can disconnect that and remove the entire project here if I need to, along with these clips that come off as well. So quite an ordeal if you're not a router, or don't know how to use a router, but this is going to work out. I'm going to wrap the this real thin cable. You can use any kind of cable, I guess. I chose some 40-pound test. I believe, well, sorry, 60-pound test fishing wire, and fished it through there and then I'll wrap it around twice here. There's a little hole there you can see, and a hole that's drilled. So they'll wrap around there, and as it turns, you get about a 4-inch pull on either side. If you just wrap it once, you'll only get about 1.5 inches, which won't be enough to turn the rudder. So here's the finished project. There's the DIY turn. It's not perfect. Gonna take some tweaking. Here's the control with the switch inside. Reverse. The power that goes to the battery box. I didn't show how I built the battery box. There's so many good ones on the YouTube. You can figure out how to do that yourself. Here's the wires that go back to the power control. And this is all removable. There's some swivels that detach here. These detach. This ring detaches. The whole project comes up. So here's the neat thing about this type of rudder and a handle. Lifts up out of the way so it doesn't rotate around. Okay, good luck with your project. Here's how I did it. I may make a few changes on it, but it works.